Hey everyone, in today's video we're continuing the build of my DIY pick and place machine inspired by the open source Lumen PNP. They did an amazing job. Make sure to check out their website and YouTube channel for more info. This project is heavily inspired by them, but except for the 3 D-printed parts, everything else is redesigned by me to be smaller, more cost-effective and custom fit. My Z-axis and gantry setup is different too, since I'm using a Juki nozzle. We start by installing the bottom camera and light onto a 2mm aluminum sheet that I cut myself. I drilled rows of holes, spaced 32 centimeters by 3 centimeters apart. Some of the holes are tapped to accept M3 screws, so we can easily mount components like the light array and the camera. The hole pattern also allows us to easily mount other components like SMD component tape, a PCB holder, or even an auto feeder for SMD components, or support head swapping for the PNP head. This aluminum plate will later be fixed to the main frame. Next, we mount the pick-and-place head onto the Z gantry. I also added the air hose and routed the camera cable through the wire guide. Before moving on, here I'm connecting all the cables I made in the previous video. If you haven't watched that one yet, please check it out. I covered a lot of useful tricks to make the cables strong and reliable for years of use without headaches. The chain guide is mounted on an aluminum bar I cut from the same 2mm sheet. Now here I made a small mistake. The cable chain I used was too narrow and didn't have openable links, so I had to feed all the cables through at once. The trick I used was to tape all the cables to a guide wire and pull them through together. I drilled and mounted one end to the X-axis gantry and the other to the aluminum bar. Voila, protected cables running cleanly along the X-axis. Here I'm labeling all the cables. Once the wires run through the two protective cable chains, it becomes really difficult to pull on one end and figure out which cable is which on the other side. So marking them now saves a lot of confusion later. Next, I routed the cables through the Y-axis wire chain guide, including the stepper motor cable and the end stop wire. It was a bit trickier than the X-axis because of the extra cables. I'll probably upgrade this later to a wider openable chain when I add a second head. For now, it works. At first, I mistakenly ran the Y-axis motor cable through the wire chain guide. But since the motor is fixed and doesn't move, its cable doesn't need to go through the chain. So I removed it and routed it directly to the control box instead. After that, I mounted the end of the wire chain to the frame using an aluminum bracket tapped for a 5mm screw. For the control box, I used a 3D printed design I found online. It's a temporary setup, mainly to test the layout and check how much space I need for components like the air pump, solenoid pump, and the motherboard. Since the box had very small cable entry points, I had to modify it. I cut or cracked open some of the existing ventilation vents to make space for the cables. Then I routed all the wires, XYZ axes, endstops, and more to the controller so we could run some tests. Now I'm installing the Calibration PCB. It's mainly used to determine the offset between the camera and the pick and place heads, which is essential for accurate placement during operation. To mount it, I'm using M3 screws and tapping the holes directly into the aluminum plate. That means I don't need any nuts. I just thread the screws straight into the plate. It saves space and makes installation much easier and cleaner. I tapped the holes earlier when preparing the aluminum sheet, so mounting components like this is quick and solid. Now I'm connecting the main plate or the working plate to the frame. I'm using M5 T-slot quick installation nuts with 5 on each side. Now it's time to test. I connected the camera to the PC and the light to an ESP32 board. I control the light through Arduino IDE and the printer is connected. started by checking all the endstops. Always a good idea to test them first by pressing each one with my finger to make sure they changed their status to triggered correctly. For this test, I removed the PNP head to avoid accidentally damaging it. I taped a pen to the Z gantry instead. It's a bit of a hack, but it works. Then I ran a simple logo design to test motion while alternating the light colors and observing how the camera captures everything. To give the camera something visible to track, I also printed a PCB layout on paper using a laser printer. Just using a blank white sheet wouldn't work well since the camera and the Z gantry are slightly offset. You'd see nothing clearly on camera. After drawing the logo, I moved it slightly by hand and applied a manual offset to demonstrate how the camera sees movement when there's no offset calibration. This gives a good visual idea of why camera head alignment is so important. In the next video, I'll be designing a custom control box enclosure to fit perfectly with my setup. I'll also wire the pump and lighting to be fully controlled by the motherboard. Maybe we'll even try a real pick and place of an SMD component onto a PCB. Thanks for watching, and don't forget to like, comment and subscribe if you're following this build. See you in the next one.